Welcome to the MSSQL Tips webcast, Journey to the Cloud, Topologies to Consider for HA SQL in the Cloud, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MSSQL Tips and today's webcast host. Joining me today is Mike Trout, who's a senior solutions architect at SIOS. Mike has been working with high availability, disaster recovery, and backup recovery solutions for over 16 years, and today he will discuss what you need to know for a successful HA solution in the cloud. Before we get started, if you have any questions, you can submit them at any time during the webcast by entering your questions in the question area in your presentation controls, and we will answer as many questions as possible during today's webcast. If you're not already a member of the MSSQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Mike and he can get started.
Thank you very much, Greg, and welcome to all the participants. Today's topic, as mentioned, Journey to the Cloud, Topologies to Consider for HA SQL in the Cloud. So here's the agenda. We just covered introductions. We'll talk about a little bit of the history of high availability in SQL with traditional topologies and even those that are deprecated in the current day, enabling that migration to the cloud. What are some of the options out there to take advantage of? And then we'll talk, of course, about SIOS high availability solutions in relation to those targets and the next steps. Here's our poll question. Greg, I believe you have a live screen coming up.
Yeah, I'm going to post this now. All right, so we just take a few seconds to answer this and just get an idea of what people are using today. So the question is, are you planning to move SQL Server to a public cloud? And I'll just take another 10 or 15 seconds here to get everybody a chance to vote, and then I'll reveal all the answers. All right, another 5 seconds. All right, I'm going to close this down and I'll share the results. All right, so we have 41% said yes, planning on moving to Microsoft Azure Cloud, 35% no plan to move to the cloud. Then we have 12% for planning to move to Amazon, as well as planning on to move to Google or some other cloud.
Okay, thank you very much for that. Interesting that there's a significant amount that have no plan to go to the cloud. I'd be interested in following up with those as to the reason why. Anyway, moving along. So we'll talk about some of the HA topologies traditionally in SQL Server, depending, of course, on version existing and whether or not the infrastructure that you may have supports it. So in the Wayback Machine, prior to SQL 2012, we'd utilize a thing called DB mirroring. Database mirroring was the basic of the basics, basically copying database to database and hoping for the best. But of course, there were some limitations in terms of granularity and stability in that topology. Then we stepped into shared storage with, predominantly SAN type of storage area networks that enabled intelligent storage to share one storage device between multiple hosts. This enabled us to create this logical availability group, have shared storage between multiple nodes, and having those nodes be essentially highly available. But it was very expensive in the sense that the whole infrastructure needed to support being able to supply that shared storage technology. You could then move into having a cluster of shared storage in one location and have that availability group realize a disaster recovery instance as a standalone on the other side of, you know, wherever that kilometer distance was. But nowadays it's more of a topic to talk about how do I get to the cloud, and when I'm up in the cloud, what are my options in terms of highly available applications and those types of topologies. So I guess we'll start off with, you know, there is no shared storage element that matches the traditional SAN shared storage that people are quote unquote used to in the cloud. So without these elements here, what am I going to do to satisfy the requirements to deploy a highly available application, in this case SQL, into the cloud topology? So this traditional cluster also presented an additional problem. Because it's shared storage, it's still one copy of the storage. So that presents a single point of failure by design, although the cluster layer of the actual servers do provide redundancy for services and network layer things. But the storage itself was still a single point of failure. And there's all kinds of money to be spent at the disk layer to ensure that never fails. But it's in a logical entity representation, it is still a SPOF, right? So now we start moving into SIOS DataKeeper in that same topology. And this could be physical or the cloud, which is a great feature because this enables seamless migration into the cloud without really redesigning the whole topology in delivering the highly available application. So not only will it replicate the two locations between any number of servers out towards, I believe, 16 copies, but I can also offer failover in tight integration into Failover Cluster Manager in Windows in order to failover network, the SQL Server service, any IP resources, any VIPs that are required. Depending on how large your build out is, this topology here makes it simple, makes it redundant, and gives you highly available resources. So there's an option to have multi-target clusters also. And in this sense, we see a primary SQL server, and I can replicate that one instance to multiple targets. So if I wanted to span a WAN or a LAN and have multiple targets, in this use case, I might have my reporting guy. He runs reports daily. So he might really drive things crazy. So I'm going to script that SQL to quiesce a database and actually pause his replication so he can run his reports. I don't have to have this just for failover purposes, right? There are many, many uses for all of these replicated instances that are out there. So if I did need a failover, I could use those hosts for failover. And if the second host happened to fail also, it would then fail over to the third host. So you can see the true resilience here, and you'll see a little hint of this in the demo a little later on, but I can not only benefit from the replication and using those resources on other compute resources, or I can have many tiers of high available protection for whatever applications I am interested in. So now we'll move into a multi-site storage with some hybrid storage options. So I could have some local clusters running, and then I could even put another node up in the cloud. So in this case, I have this replication going from my local data center, and given latency requirements, put another synchronous copy up in the cloud. If latency does not quite meet the requirement, I could have an asynchronous copy up in the cloud for test, QA, upgrades, whatever the purpose may be. Or maybe this is the initial seed on my journey to the cloud, right? To essentially migrate all of my on-prem up into one of the cloud vendor solutions. So here's an example of our Microsoft Azure relationship, and they use these terms called fault domains, right? So I don't want to have two nodes supposedly protected and have it be in the same fault domain, because if that fault domain ever went down, I would lose everything. So there are a couple sensitive things up there where you need to be aware of, which fault domain you're dealing with. But this will cover, again, failover and replication. And then, of course, I have a third entity for a file share witness as a best practice for keeping an odd number of quorum. Same thing in our Google Cloud platform. We're a Google partner up in the Google Cloud, and they call their failover zones US Central, US West, US West D, etc. So again, the same type of failover, the same type of replication. At the compute layer and the SIOS implementation, there's nothing a whole lot of, it just doesn't present a whole lot of unique requirements per platform. The platform unique requirements are more driven by deploying a topology in the cloud, regardless of whether it's SIOS or not, right? So we don't have to change the way SIOS gets implemented in either Google or Microsoft or AWS. There are some sensitivities there that are well documented, but mostly for the network and those layers above. And then finally, Amazon, we're in their partner network. It's Amazon, AWS, and EC2. So this, again, it looks the same because it is the same. It doesn't matter which cloud we're going to or which cloud we're integrating with. If I have a hybrid model even, I can get this same result from the SIOS because we're running inside of the OS. There is very, very little in terms of uniqueness or things you have to really be cautious of in terms of SIOS implementation. So now let's step back and who are we? Who is SIOS? Well, we were founded in 1999 and our former name was Steel Eye Technology. Our headquarters is in San Mateo, California. I'm speaking from Maynard, Massachusetts, just outside of Boston. And we have offices across the US, UK, Japan, Asia Pac, etc. And we're recognized experts in application availability. So interestingly enough, traditional HA was always about very expensive infrastructure in terms of fiber channel switches and very expensive disk backends with really intelligent microcode in them to enable highly available solutions. But SIOS sort of stepped back and took advantage of the simplicity. So more than 70,000 licenses was the last count I heard, are installed globally in a wide range of industries. So it's not unique for any specific vertical, for healthcare or defense contracts or what have you. We span everywhere because we're not sensitive to those specific use cases. We're in the highly available layer of that stack, which applies to any and all industries. So as you can see on the right, we have a wide array of partners and industry leaders that we work with to qualify on an ongoing basis, keeping up with the next gen. As a prime example, SQL 2016, we already support today. And the mission critical applications, this is a subset of applications, and some of these actually are platforms rather than apps, but we cover the whole gamut of being able to provide highly available assurance for the tier 1 apps that you're dealing with day in, day out. What's not shown here are any of the Linux flavors, the SAPs of the world, and any other Unix type of application. There is a sister product for the SIOS Protection Suite of Linux platform too. But of course, this is a SQL topic, so we don't include that in our slide decks today. So the DataKeeper Replication, I guess just as a summary, the key features, it's a host-based data replication, leveraging your existing LAN or WAN. So we'll take an equal set of volumes from a pair of servers or more than a pair, and we will use the network to get a synchronous copy in the event it's LAN speed, right? If I had to, because of latency, I could also get an asynchronous copy. And these copies can be anywhere from 1 out towards 16. for each volume. It's block level, volume and LUN level replication, and we use this bitmap file that enables us to be very efficient. If you have to break your mirror for some, one-off reason to use maybe that second copy for something else, in terms of reading for reporting, you can resync it very efficiently because we keep track of all the changes in what we call a bitmap file in our solution. So, and here's just a sort of a comparison in terms of what are my options with SQL. What flavor of SQL additions deliver this type of protection? So I won't read every line here for you, but I'll keep the slide up for a couple seconds just to give you an idea of, sort of the migration of, I can have always on availability groups, but do I get, all of the features that I am after in terms of the ease of administration, usability, what's the granularity, how many copies can I have? Do I need more licenses if I add more databases? Where are the limitations there? So it's got this bullet list with a feature function between three options. Of course, on the far right, DataKeeper delivers all of these requirements. So I guess the SIOS advantage in summary, we deliver the high availability for those tier 1 business critical applications. The flexibility, Windows or Linux, as I mentioned before, in any combination of physical, virtual, cloud, or hybrid combinations therein. There's very high performance. It's fast, it's efficient. The block level replication, utilizing that bitmap file, keeps things very lightweight. And the low TCO, that total cost of ownership, is very low. I don't need really expensive enterprise level licenses in order to deliver an HA result. I can have a very efficient purchase of a SIOS solution and not realize an enormous amount of license costs or complexity of either SAN or advanced licenses and enterprise editions, et cetera. And then the unique application awareness. So we don't just monitor the disk. We integrate completely with Windows cluster services. And the Failover Cluster Manager, you'll see in the demo in a second, is truly integrated seamlessly into it. And we'll dive into that right now. So I have 3 virtual machines running inside of my sandbox right now, my virtual box on the Mac, and I'm just going to log into my primary SQL 1. Just give you a little background. So I have 3 nodes. 2 of them are my clusters. I don't have a quorum. I don't have a third for a quorum, and I don't have anything larger because I need it to be lightweight to fit on my laptop. So this is by no means the best practice topology. It's just a point where I'm replicating a couple of drives for the purpose of SQL, and then I'm replicating some one-off drives. And that's where the third node comes in. So let's get to a place where we're used to seeing happiness, right? So I have my SIOS SQL cluster. That's my cluster resource name. And its role it's owning, of course, is SQL Server. So SQL Server right now is primarily on SIOS-SQL 1 node, and that's the node that I'm showing the FCM right now. I'll have 2 nodes, the SQL 1 and SQL 2 nodes. And then when I get into the storage, this all looks just the same as any other cluster you've ever seen. Then you'll start seeing hints of uniqueness. So I have this DataKeeper volume S. That's the S drive that's seen by either node. Whoever owns it is the primary. And if I go into properties of this, you'll see a little more hints of the integration. So I have general information, what dependencies exist, etc. And then I have a tab called DataKeeper Volume Parameters. I can click this, and now I see that I have my source system of SQL 1, that's the host that's hosting SQL Server, and that's the current owner in the cluster, but I have this S drive. I see the target system for its primary copy is SQL 2, which I mentioned in the topology overview in the beginning, and that is receiving a mirrored copy of the S drive. So, and it's a synchronous copy. So right now, the state is mirroring, it's synchronously mirroring. I have the S drive here, S drive there, and then I see a third guy out here. What's he doing? Is he a rogue in my environment? No, this is my SIOS 3. SIOS 3 doesn't even have SQL installed on it. I put a third copy out there just to put the use case thought in people's minds that I can take this disk and copy it to anywhere. So, I mean, maybe this is a dumping ground for some reporting server that just comes over and maps to things and runs a bunch of reports against my SQL stuff so that my production hosts are not bothered by that overhead. Or maybe it's just there for, some paranoid redundancy reason. Maybe I can install SQL on this and then actually use this to migrate my instances or builds or update things, right? So I have 3 nodes involved. That's the hint. Let's go into the DataKeeper GUI now. And this is where you sort of see the back end. I normally don't live here though, because when I administer SQL, I just stay in the Failover Cluster Manager UI, business as usual. Very seldomly do I really need to open up this GUI, which is a huge feature of the solution. It seamlessly integrates. It's almost like a set it and forget it type of feel. So I can see my source server SQL 1, and target is SQL 2, and the current state is mirroring. And here's my 2 IPs I'm using for Compass. And then I also see this. Look at SQL 1 is also mirroring to SIOS 3, but he doesn't have SQL on him. I'm just replicating that volume again for the use case as I mentioned before. I see the mirror type is synchronous. There's the size. No compression because it's local LAN. I'm not sensitive to any bandwidth issues. And I can get more details on the source server, the target server, etc. So that's all good and great. I also have a couple one-off drives I'm replicating. Replicate payroll. I figure payroll is an important thing. So I chose the payroll name for, again, SQL 1 has an E drive that's replicating to SIOS 3 because my payroll information is on this volume. Okay, just to prove the point, it's not specific for SQL. This can replicate any volume. And then replicate E is actually replicating the source volume E to the target volume of a different drive ladder on another host. Not quite the best practice because you can easily confuse different drive ladders, but just to prove the point that it was possible if you needed to for some one-off reason. So now let's cause trouble because everybody likes to see trouble in a demo. We almost had trouble before the demo started, but it's because my Mac went to sleep and things didn't want to wake up. So I'm going to take a look at this, and we know that SQL 1, the SQL cluster volume is S down at the bottom here. I'm going to take a look at SQL 1 in my disk management, and I have that selected. I know that this drive number 1 is actually my S drive, so I'm going to do things that will make people gasp. Take it offline. Do you want to take the disk offline and just destroy your SQL? Yes, I do, because I have confidence in the solution. So as fast can be, let's take this up here and take a look at what's happening. So already the switch is underway. You're going to see these update into a non-mirrored state, and then SQL 2 knows that it has to come up. So as soon as I spoke about it, you already see in Failover Cluster Manager, my role is still running, right? So before I could even explain the failover occurring, it already failed over to the second node and is, happily running. Now, it's owned by SQL 2 now, and I'm not going to get a happy status from my job for the reason being, it cannot get to SQL 1's volume copy because I took it offline because I did something very mean. An interesting point I need to show you though, look at SQL 2 also took over the primary copy job to get that third copy out there to SIOS 3. So that sort of resilience and awareness is built into the product. The product's been out there for decades, and it's obvious. It's a great hardened solution. The use cases applied really deliver seamlessly and easily without the need to tiptoe around things once it's implemented and in use. So let's fix her up. We'll get this back to happy again, just to see the recovery. I'm gonna bring the volume online. I hope I'm quick enough because it happens fast. So volume's online. This will come back and realize that the volume's back, and it's already mirroring. It beat me. So, and you notice it temporarily paused the other copy too. So let's get these guys back to where they belong, because remember, I live in Failover Cluster Manager. I don't want it on SQL 2 anymore. I want to move this, select my node manually, go to SQL 1, and say go. And now watch what's happening in the background. You'll see this too change to the 1, so don't blink. But that's just the point of the seamless integration. I don't have to manage things with a new UI. I could use what I'm used to, the Microsoft MMCs, etc. And there it goes. SQL 1 is taking over everything now. It'll go into a temp resync, check the bitmap file differential, and then gain mirroring status again once it's synchronized. So that's the summary of the demonstration. And I think we ran through quite the number of use cases in that time. So very good. We'll go back to the slide deck now. And we hit the poll question, and that's the summary for this session today. A lot of discussion of the clouds, the topologies. Maybe this cleared up some of the options, or maybe some of the restrictions where you say, I can't go to the cloud. They don't offer a valid HA solution for me, and I need highly available instances. These are tier 1 applications we're talking about. So thank you all for coming. I know Greg will have some closing comments, but if you need to contact us, you can go to the website listed on the screen, us.sios.com, and we'll open it up for Q&A to discuss any questions that might have come up. You guys have the...
Okay. Thanks, Mike. Yeah, we'll take some questions. If anybody has any other questions, feel free to just type them in the question area. We'll just take them one by one. So one question that came up, Mike, was related to using Azure SQL database, and they're just wondering, is that something that could take advantage of the SQL, the DataKeeper tools that you mentioned today?
I'm not sure. Dave, do you have a comment on that?
Yeah, I assume they're talking about the Azure platform as a service, SQL Server platform as a service, and no. So DataKeeper has to run on a Windows operating system. So, in the Azure SQL as a service, Microsoft manages that platform. So there's limited options in what you can do, and you can't install third-party software to do any sort of replication. So, unfortunately, no. The solution is good for physical, virtual, and cloud. Assuming cloud, you're talking about infrastructure as a service where you're managing the servers themselves.
All right, another question that came in was related to just migrating databases from on-premises up to the cloud. And they're just wondering, what are some of the things that they should be aware of and the steps they need to follow to actually have a successful migration? Do you guys have some thoughts on that?
So the migration, the sensitivity is all about the network layers in my mind. Do you have valid latency without needing to really forklift everything in a massive outage? But the SIOS solution can alleviate some of that pain, or at least reduce the time of outage, because I could use a synchronous or an asynchronous copy to get there. And if I did have to have a massive quiesce event in order to get that asynchronous copy caught up with and then create some other copies on the cloud side, that could certainly enable that to happen. And I think Dave has seen a lot of sort of the network sensitivities, especially in the Azure tiers, right? As far as, you know, needing your load balancer up there and making sure the networking layers are configured correctly. That's the most exceptions I've seen, you know, coming in from this side.
Yeah, I think that, you know, one of the biggest challenges of migrating to the cloud is, especially with large data sets, is getting the data into the cloud and, you know, minimizing the downtime associated with making that migration from on-prem into the cloud. So the DataKeeper can certainly assist in that process, where you can configure a mirror to go from on-prem to the cloud. And again, depending upon your network connection, whether you're using a private, you know, express route or direct connect, or versus a VPN. And then, you know, depending upon how much data you have, the initial sync could take hours or days. You know, it really, you know, it all depends on the amount of data. So using DataKeeper, you can kick off the job without impacting the production system. And as soon as the mirror gets in sync, then you are ready to, you know, preferably do a test migration where you can spin up some instances in the cloud using a copy of the data at that given point in time, verify everything is working as expected, and then plan for your final cutover. And so to do that, you would essentially reverse the direction of the mirror. I would suggest you reverse the direction of the mirror so that you bring things online in the cloud, you're running in the cloud, but yet you have of the data on-prem, just in case you want to roll back and say, you know what, we didn't account for this or that or the other. Then moving back to on-prem is not going to entail doing another whole copy of your data, because doing the mirror reversal, you're only doing that partial resync. The mirror is going to maintain its mirroring state so that you can bring things back online on-prem should you need to roll back. So DataKeeper can certainly help out in that situation. That's probably the hardest thing is getting your data up there and minimizing the downtime associated with that migration.
All right, the next question is related to mount points, and so we're just wondering, does SIOS DataKeeper support mount points?
Yeah, mount points are not supported. If you think about a mount point, it's really just a pointer on a volume that points to a different volume. So if we're not replicating that volume that it's pointing to, that data won't be there upon recovery. So mount points are not supported because the data you know, referenced by the mount point is not being replicated.
All right, let's see. Another question came in that's related to the need for additional HA functionality in the cloud. So somebody just wondering, doesn't the cloud offer everything that they need for high availability, or do they really need to implement something additional for SQL Server to protect it?
Yes, so they offer redundancy in terms of attempting to make things available, but at the layer of your operating systems and whether or not that application is actually failover HA protected, that's not where they live. They offer the infrastructure as a service, so to speak. Maybe that's a little different in the SQL on Azure as a PaaS solution as opposed to the IaaS solution. But this is sort of why we're here today, right? So that highly available layer inside of your operating systems that you're implementing, it's not provided directly by the cloud, and you don't have access to the shared storage elements to ensure that the SCSI reservations permit shared storage layers, etc.
Yeah, I would just add that if you look at the SLA published by Azure and AWS, they're going to be very specific that in order to qualify for any SLA, you need to deploy 2 or more instances in different availability zones or fault domains. And then what they're guaranteeing is that at any given time, you'll have what I call dial tone access to at least one of those servers. So that's great for web servers and application servers that don't have dynamic data that you can simply load balance between multiple instances. But when it comes to SQL Server, you need a way to keep the instances in sync at the data layer. So DataKeeper will do that for you, and failover clustering will ensure that at least one of those nodes is up and running. So you certainly need to take into account, plan for high availability in your deployment in the cloud, just as you would on-prem.
Okay. Let's see, another question so we just wondered was about features on the cloud versus on-premises. They're just wondering, are all the features available for SQL Server if it's running in the cloud environment? Can you just kind of talk about that quickly?
In terms of DataKeeper or SQL
just
Server
SQL
in
Server.
relation to DataKeeper?
Yeah, for SQL Server. So if somebody's migrating the cloud, are they going to lose any functionality from a SQL Server perspective, or are they?
I don't believe so, but I'll defer to Dave, the MVP for SQL, for that one.
Yeah, I mean, infrastructure as a service is going to be exactly the same. You manage it. You can enable whatever features you like. If you're talking about platform as a service, then yeah, it's not 100% the same. So that's the biggest thing when people are looking at cloud. Do I want to manage my own SQL instance like I have been for years, or do I want to take advantage of the SQL Azure or Google, whatever cloud provider has to offer? It can be, you think about letting, Microsoft manage your SQL Server on the back end. If it's a greenfield and you're building new and your developers are familiar with the platform and familiar with the limitations and you can live within the parameters that they're offering, then, platform as a service can be interesting. But there are certain limitations that you need to be aware of. So you want to make sure you investigate it fully before you make that decision of infrastructure as a service versus platform as a service.
All right, another question that came in was related to just setting up a test development environment just to test everything out. And somebody just said it just takes a lot of time to do that. Is there any quick way to get an environment set up to test clustering and the DataKeeper tools?
Yes, it depends on which cloud provider you're dealing with. So we're in AWS Marketplace, ready to go with SQL builds, and the SIOS solution is built into those pairs. Or in the Microsoft platform, we have GitHub inclusion in the GitHub Azure area, which will walk you through the simple steps to get the solution ready to go. It's really lightweight. There's not a whole lot of need to be handheld all the way through. But there's turnkey right now. It's in AWS. It's going to be in the Microsoft platform as a turnkey solution soon. And Google Cloud Platform is the third target to match the same ease of deployment that AWS realizes today.
Okay. And then somebody just asked a follow-up question about AWS. So is it like a several hour, or a day, or a week time to get it implemented, or how quickly is it to kind of throw something up based on that?
Let's look. So I deployed 2 VMs on my laptop as an example, right? So, I mean, aside from the cloud overhead of deploying a virtual machine on the cloud, that's just a cloud overhead, right? But as fast can be, I can allocate a couple matching size volumes. I can implement the lightweight package of DataKeeper for cluster addition. And then once that's ready to go, I can synchronize those 2 volumes and then install my 2 copies of SQL cluster addition on each host. So as fast as that happens is as simple as the implementation will complete. Right. Some of the SQL installs are. Yeah, go ahead, Dave.
Oh, I was going to say, they might have been referencing the quick starts that we have. So, you know, in the essence of a quick start, in Azure GitHub, you can take, you know, a minute to fill out the form, you know, collect information like username, password, instance size, region, click go have lunch, come back after lunch, and your 2-node cluster will be up and running. Similar experience in AWS with the quick start there. You spend a few minutes filling out some information, and then click go have lunch, come back, and you got your 2-node cluster up and running. And in AWS, you even have the ability to integrate with existing VPCs, existing domains. So you can really leverage that to, you know, to implement new SQL Server deployments in existing environments. So that, you know, it's a pretty simple process, even if you're, you know, it helps to be familiar a little bit with failover clustering, so you know what you get at the end of the day. But anyone can, you know, fill out forms and have a failover cluster up and running in an hour or so.
Okay, great, thanks. All right, another question that came in was related to virtual environments. They're just wondering, does a solution only work in the cloud, or if they're running VMs on premises, is something they could use the DataKeeper solution for as well?
Yes, Hyper-V, VMware, et cetera. So it's basically any environment that offers the OSs that are supported with equal volumes and IP connectivity between the two. It's basically the easiest description I could give you as far as where can I run my VMs, right? So we're not restrictive in that sense.
Okay, and then another question here that just came in is related to doing a hybrid implementation. So can they have something in the cloud and on premises at the same time and replicate data?
Could you repeat that, Greg? Sorry.
Yeah, I was just wondering, like a hybrid implementation. So could they have the server in the cloud and the server on premises and replicate the data with DataKeeper? Is that a solution possible as well?
Yes, that was actually one of the sample topologies we went through in the slide deck. And that's also what Dave mentioned as a migration option. Once you get data synced and the primary is in the cloud, a lot of people reverse the synchronization and actually synchronize back to an on-prem copy.
All right, another question is about the installation of DataKeeper, and just wondering how involved is that, or is that pretty trivial to get that set up to actually use for the cluster?
Yeah, it's really straightforward. It's as simple as long as you have those two volumes prepared that are equal size by best practice, and as long as the primary is as big or the target is bigger, then that's the only disk requirement, and then the rest is click, click, click. I mean, you just have to be aware of how you're using the volumes in your topology map, right? Nobody will just blindly install it. You'll have to be aware of which nodes am I expecting to replicate this data to or from, and how many nodes involved, and do I have the IP interconnects correctly prepared? And of course, you're not going to have just a single IP in between the nodes. It's best practice to have a second COM path, as we call it in DataKeeper documentation. So that's about the only sensitivity that exists. It's really not more complicated than that. It's very straightforward.
All right, another question is related to what is actually replicated. So is the entire server replicated, or is it volumes or drives or folders? Can you just kind of talk about that a little bit?
Yeah, so it's a block-based disk replication. So the real heart of this is the block-based disk replication relies on our bitmap file that we track changes with. In synchronized topologies, we don't get an ACK back until it's written to both or all targets in the event you have more than two involved. And on top of that, our integration and awareness of the Failover Cluster Manager and Microsoft Cluster Services they all talk to each other with the APIs that are available to keep things, you know, in their dependencies, in those relationships. That is the next critical component. So it's not a complete server copy. It's more of the typically databases, and then services and network resources between multiple hosts. That's the simple description for an answer, right?
Okay, another question related to patching the different servers. So they're just wondering, if you implement the cluster in the cloud, are you able to patch one server and have the other one running and then kind of switch like you do on premises? Does that all work the same exact way?
Yeah, just like the demonstration. I mean, that's a perfect use case to have a number of nodes involved in a highly available group. So yes, I could switch my primary to another node in the cluster, and then I could even break that mirror for reboots or whatever and pause that relationship, but the other two will live on, right? So I could still have high availability as I roll my patching or updating or upgrading.
Okay, another question is related to, oh, sorry, go ahead, Dave.
I was going to just add to that you know, this is really one of the primary use cases for a failover cluster versus, you know, thinking more about virtual environments where you have VMware HA or Hyper-V, high availability. It gives you a certain level of protection for, you know, should physical servers fail, virtual machines will, you know, restart on other servers. But it really doesn't account for planned maintenance if you're just simply relying on VMware HA or another, you know, high availability for the virtual machine itself. By clustering at that, you know, guest level, you know, for SQL Server, you can have maintenance with minimal downtime versus if you don't have it clustered and just doing host-based clustering, VMware HA. If you ever have to patch the VM itself, you have to schedule downtime because there's only one instance of it. So that's certainly one of our bigger use cases to minimize that planned downtime.
All right, another question is related to replication, and just wondering, is there any distance limitation as far as how far apart, or is it just a matter of internet access, broadband access? And then secondly, is the data transferred synchronously or asynchronously when it's in the cloud?
So the latency number, I believe, Dave, what's the recommendation for synchronous? 20 milliseconds or less?
No, usually a lot less than that. So if you're doing synchronous, then the latency you're going to want to have, you know, 5 or less milliseconds. But typically, it's going to be the same LAN, local area network, or, you know, a fiber channel connection that's, you know, within a few miles of each other. Minimal latency, because, you know, synchronous, because we do support synchronous or asynchronous. You know, the more latency on the link, the more overhead there's going to be with any write operation, as that write has to be committed in both locations. Asynchronous is there is really no limitation in terms of latency. We have built-in WAN acceleration and WAN optimization. And when I first joined SIOS 13 years ago, one of the first things I witnessed, which was pretty incredible, we were doing replication. It was a IBM facility in New York City. We were replicating a database from New York to Japan and showing real-time failover. So you can imagine there was a little bit of latency on that connection, and it works flawlessly. So latency is not an issue. The bigger concern is bandwidth. You want to make sure you have enough available bandwidth to support what we call rate of change. Rate of change being simply how many bytes or how many disk write bytes per second. If you use perfmon, you collect disk write bytes per second on the volumes you want to replicate. Before compression, that's going to be the exact amount of data that's going to travel across your WAN connection. Now you can enable compression depending upon the data type and how compressible it is. You're going to save some, maybe 3-to-1, 4-to-1 compression, depending upon your workload. but that's a bigger concern than latency, is making sure you have adequate bandwidth for your rate of change.
Okay, another question related to the replication. So you mentioned in the presentation that you're doing block level replication. So somebody's just wondering, when there's a failover, how does it ensure that there's consistency on the other machine when the recovery occurs? Can you talk through that a little briefly?
It's all about the awareness in the bitmap file. So if it's in synchronous mode, you won't get an ACK back until that second copy is written. So, and it updates the bitmap file to be aware that this data represents the written block that just came across the wire. So in that sense, everybody knows who is where. There's also an option for, a quorum vote to say who is the winner, right? But that's just standard cluster technology being involved in that. There are cases where, if something drastic happened and everything went away, the SIOS software actually keeps track of who was the last known primary copy of this data. So at the worst case scenario, we at least know that, right? And outside of that, I can't control hurricanes or tsunamis, right?
Okay.
Yeah, I would just add.
Sorry,
I would just say add to that is that as Michael was mentioning, we leverage a bitmap file to ensure that the data is managed properly. The biggest thing is that the data order, the right order integrity is always maintained. So regardless of whether it's synchronous or asynchronous, the right order integrity is maintained, even across multiple volumes, which is common if you have your data files on one volume and log files on another volume. You can be sure that even in the event of unexpected failure, that the data is in a crash consistent state. So similar to a shared storage cluster, if you were to go and pull the power cord on the primary server in the middle of a transaction, when the secondary server starts up, it's going to look at the log files or the data files, and it's going to roll back any uncommitted transactions. You'll see SQL doing what's called a soft recovery. Same thing happens in a SANless cluster with a unexpected failover. The data file and log files are going to be at the same point in time, so SQL will recover from that, doing a soft recovery.
All right, another question is related to versions of SQL that's supported. Does this work with pretty much every version of SQL, or are there?
Could you repeat that question, please?
Yeah, which version of the SQL Server does DataKeeper work with?
That's 2K8R2 and above, including 2016.
Okay. And another question somebody asked just related to, if this is implemented and they had an issue and contacted Microsoft, is it fully supported and Microsoft would help them out with their SQL Server Windows issues?
Yes, there's a relationship there, and it's qualified by Microsoft in our partnership. Dave, is there official documentation / wording to that sense?
Yeah. I mean, we are a partner. The solution is certified for Windows Server 2012, Windows Server 2016. We are actually a recommended solution for high availability. If you read the documentation on Azure, we're a certified solution for SQL Server as well as SAP. Standard, the standard procedure is when you are a customer of SIOS, you have a support contract that is 24/7, 365. And if there's an issue, you will call us. Now, we are covering the DataKeeper portion of that, so we get many calls that people are having an issue with their cluster. Turns out that it's not really DataKeeper related. They had a failure of the cluster, failed over. We do the initial triage and say, well, it looks like your network stack went down. The cluster detected the IP address failed. It caused the failover. Everything's good. You might want to investigate this further with Microsoft. Same thing. If someone calls Microsoft and said, hey, I have this problem with my cluster, and Microsoft identifies the issue at the storage layer, just like if you were using an HP SAN or whatever your SAN vendor might be. If there was an issue with the storage, that Microsoft says, hey, let's get HP on the phone and let's troubleshoot this issue. Same thing applies with SIOS. If they need storage layer.
Okay, another question somebody asked was related to implementing a cluster and using DataKeeper across multiple cloud providers. So is it possible, or have you guys actually seen this, where somebody's implemented a server in AWS and then a server in Azure, and they're actually replicating data between the two cloud environments?
I have not seen that in context, but it is part of our sort of reference architecture. Just a few months back, an unnamed cloud provider in Virginia area had a massive outage that cost retailers, banks, et cetera, a lot of money as a result of that outage. Now, they could have had redundancy within that one data center and that one cloud provider, but having that second copy, if somebody used a Google Cloud platform, an on-prem copy, or even the other provider for cloud, as that second copy, that would have sustained their tier 1 apps, and they would have kept on going. So yes and yes.
All right, another question came in about the SQL Server services and for clustering. This is more just a clustering question. So basically any service that SQL Server has that's cluster aware will work for a cluster in the cloud. Is that true?
That's correct, except for the one SQL. What's the single service that is never cluster aware? Dave, do you recall? It's not on the tip of my tongue right now. Is it the agent or the
reporting services? Maybe there's some things that are you're kind of workarounds, but essentially DataKeeper just provides storage for failover clustering. So anything you can cluster with the traditional shared storage, you can cluster with DataKeeper SANlessly.
All right. Well, we're just about out of questions. So is there anything you guys want to add before we wrap things up?
Yeah, I mean, so in closing, there's a very easily acquired eval option. You could go to the Contact Us page or call either one of the numbers or email the sales at us.sios.com and easily get an eval set. If you felt the need to show how simple HA can be achieved with a SIOS solution and get some buy-in, and maybe that will open up the doors for something that's negating you from considering going to the cloud. And hopefully this helped in that sense. But regardless, there's the contact information. We can get a 2-week eval key out in short time, and you'll see for yourself how straightforward the solution can be.
Great. Thanks, Mike, for sharing all the information today, and thanks, Dave, for helping out with the questions. Once again, the webcast was recorded, and you will receive a follow-up email with links to view the archive and also to download the slides. Also, please visit MSSQLtips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MSSQL Tips. Thank you for attending, and have a great day.